Hello everyone, the last lesson was about parallelograms, and this lesson is about a special parallelogram, which is a rectangle. First thing that we need to know, rectangles have all of the properties of parallelograms besides they have four 90 degrees angles and the diagonals are congruent to each other. So let's go over them one by one. A rectangle has all the properties of a parallelogram. So let's go over what we learned in the previous video. We learned that opposite sides were congruent, like these two, and TS and UR are congruent because rectangles are parallelograms. Other than these, we learned that the opposite angles were the same, like angle T and R gonna be congruent, U and S are congruent. Besides this, what we learned was diagonals bisect each other. Like let's say this is three lines. This one is going to be the same, QR, and UQ and QS are going to be the same. And we also learned that angle T and U are consecutive angles, and the sum of these two angles are going to be 180 degrees. So besides all of these, there's two more. The first one is the angles are 90 degrees, like T, S, U, and R. So what happened to the other properties that we talked about, like the consecutive angles are supplementary. So if you look at these carefully, angle T is 90 degrees, U is 90 degrees. If we add them together, the answer is 180 anyway. And the opposite angles, they were the same. They are still the same, 90 degrees, 90 degrees. And one more thing, the diagonals are going to be congruent, which means TR and US are going to be the same. There is only one way for this to happen, which means all of these are going to be the same. TQ is congruent to QR, QS is congruent to UQ. All of them are going to be the same, so let's put the same symbol on all of them. Like this. So these are all properties of the rectangles. Let's have a couple examples. Here we have two examples about rectangles. Let's read the questions. Quadrilateral RUTS is a rectangle. US, the length of US is 6x plus 3. US is one of the diagonals. The other one is RT. That's the other diagonal is 7x minus 2. So what we learn about diagonals of rectangles is they are congruent, like TR and US are the same. TR and US are going to be the same, so we have their measures 7x minus 2 and 6x plus 3. These are the same. Let's subtract 6x on each side. X minus 2 equals 3. We add it to each side, and then x would be 5. We needed to figure out the value of x, and then we found that x equals 5. So we are done with the question. We can move on to the next one. Let's see what is given. What we know about RUTS, it's the same figure, is a rectangle. Now, one angle is given, STR is equal to 8x plus 3. First, let's locate the angle. STR is right here, that angle. So let's locate it and then mark it with blue. And I know the measure of this angle. The blue angle is 8x plus 3. The next thing that I know is angle UTR's measure is 16x minus 9. So let's locate that angle as well. UTR. So we are surrounding this angle right here. So let's use different color for that. And the measure of the orange angle is given 16x minus 9. Now, if we think about what we know about rectangles, we can easily solve this one. What we know is all of these angles, like angle U is 90 degrees, angle R is 90, angle S is 90, plus angle T is 90 degrees. So if you look at angle T, that corner, it includes two different angles, the orange one and the blue one. The sum of these angles must be equal to 90 degrees. What I mean is 16x minus 9 plus 8x plus 3. These are the two angles that I have. The sum of these two must be equal to 90 degrees. Now we combine like terms. 16x plus 8x is 24x. Negative 9 plus 3 is negative 6. Sorry, not x, just negative 6 equals 90. We add 6 on each side. So 24x equals 96. We divide each side by 24 and get x equals 4. But we are not done yet because the question is about finding the measure of angle STR. So let's see what angle that this is. Angle STR is the blue one. So we know that the blue angle is 8 times x plus 3. It was given right here. So right here we figured out what x is equal to. It is equal to 4. So let's plug it in for x. 8 times 4 plus 3 equals 32 plus 3, which is 35. And we are done with this question as well. Now, time for more practice. We have two more examples here. The first one is, both of these figures are rectangle, by the way. So let's see what is given. If measure of DBC is equal to 10x, so let's put it on the angle. Angle DBC is right here. Let's mark it with blue and put its measure on it, 10x. The second given angle is measure of ACB. Angle ACB is right here. And that orange angle is 4x minus 6. Find measure of ACB. Measure of ACB is the orange angle, by the way. This is what we need to figure out, but first we need to know what x is equal to. Let's get started. So if you look at the figure carefully, one of the properties of the rectangle is that the diagonals are congruent and they bisect each other, which means these two are the same, BE and EC. So segment BE is going to be congruent to segment EC because the diagonals of rectangles are the same and they are bisector. They bisect one another. So now this leads us to another conclusion, which is we have an isosceles triangle here. This triangle has two congruent sides. That means we have an isosceles triangle. BE and EC are the same. That means the side opposite these purple sides are the same. So opposite EC, we have the blue angle. Opposite BE, we have the orange angle. They are the same. So let's set them up equal to each other. 4x squared minus 6 equals 10x. So we are going to put everything to the left hand side by doing the opposite of the right hand side. Subtract 10x. So 4x squared, there's no like terms on the left hand side right now. We are going to write them next to each other. We are not combining, adding, or doing any other stuff. Now we need to solve this equation. It's a quadratic equation. So there's a shortcut to solve this. Here's how we do that. First, write the factors of 4x squared, like what times what equals 4x squared. So I'm going to start with 2x times 2x. So if I time 2x and 2x, I get 4x squared. Now I'm going to do the same thing for 6. But at this point, it's going to be like trial and error. So first, because there is a lot of numbers that are multiplied to 6, like 6 and 1, 2 and 3, we can even switch them. 3 and 2, and 1 and 6. And they really matters. It matters which one we choose. There's only one way to write this, by the way. So I'm going to start with 6 and 1. So what I'm looking for is these two numbers need to multiply to negative 6. But if you look at the numbers carefully, both of them are positive. If we multiply them, we get positive 6. So one of them should be negative. So I'm going to just try and then see if this works. I'm going to say negative 6 and positive 1. So now at this point, we are going to do cross multiplication. 2x times 1 is positive 2x. 2x times negative 6 is negative 12x. And I'm going to add these together to see if I'm getting this number right here, that term. So 2x plus negative 12x gives me negative 10x. So as you see, this term and that one, the one in the middle, is the same. So that means I can pair the numbers and terms that are in the same line, like 2x and negative 6, 2x and positive 1. So I'm going to take them to the side and then write it over here. 2x minus 6 times 2x plus 1. Please be careful that you use the same signs with the numbers. This one was a positive number. It is still positive. These two are positive. They are still positive. So what I have here is, instead of this whole equation, 4x squared minus 10x minus 6 equals 0, I have 2x minus 6 times 2x plus 1 equals 0. So now, as you know, one of the basic algebra properties, if two terms are multiplied to 0, either one of them is going to be equal to 0, either the first one or the second one. So if the first one is equal to 0, what we have is 2x minus 6 equals 0. If the second one is 0, the answer is going to be this. So let's solve the equations. If we solve this one here, add 6 divided by 2, we get x equals 3. If we solve the second equation by subtracting 1 from each side and dividing by 2, we get x equals 1/2, or negative 0.5. But if you think about the numbers, the values that you find, this one is negative, this one is positive. So if you plug it in, a negative number here, like 1/2, negative 1/2, 10 times negative 1/2 is going to give us a negative angle, negative 5 degrees. So angles cannot be negative. They should be positive, or 0 at least. So this is the solution. That's the answer of the question, not this one here. So we can cross that one out. This is not going to be the answer. So if x equals 3, then the measure of angle ACB, remember angle ACB was this, 4x squared minus 6. 4x squared minus 6 is going to be equal to 4 times 3 squared minus 6. So 4 times exponential comes before multiplication. Remember order of operations. 4 times 9, because 3 squared is 9. Subtract 6. 36 minus 6 equals 30. So the measure of the orange angle is equal to 30. Now, the next question, we have a rectangle again. If AB is 6y, so let's figure out where AB is. It is 6y right here. BC is 8y. The longer side of the rectangle is 8y. The shorter one is 6y. Now we need to find the length of BD, which is one of the diagonals, in terms of y. So one of the properties about rectangles is that the diagonals are the same, like AC and BD are congruent. So instead of BD, if I find the measure of AC, they're going to be the same anyway. So let me underline what we need to find now. If we find the length of AC, then we are going to be done, because AC and BD are the same. These are the same. Now, if we just pay attention to the figure we have here, it's a right triangle. We know it is a right triangle because this corner is 90 degrees. It must be 90 degrees because this is one of the properties of rectangles. Now, what we have is this kind of figure now. 90 degrees, left side of the triangle is 6y, this side is 8y. Now, this is a question mark. We need to find it in terms of y, which means the answer is going to have only numbers and y's. So if you remember Pythagorean Theorem, which is a squared plus b squared equals c squared. A squared plus b squared must be equal to c squared. So it's going to be this way. Instead of a, one of the legs is 6y. The other leg is 8y. We are going to square that equals c squared. We don't know what that is. We need to find what c is equal to. So let's get started. 6y squared is square 6. You get 36. Y squared stays the same. 8 squared is 64. Y squared stays the same. The right side, it is simplified. We can't do anything with c squared. It's going to stay that way. So now, let's say this side was c, by the way. We are going to figure that one out. So these are like terms. We have 36y squared and 64y squared. If we add the numbers, since they are like terms, we have 100y squared on the left hand side and 1c squared on the right hand side. Now, time to cancel things out. We have squared here. We need to do the opposite of square, which is square root on each side. Now, square root and square will cancel out. On the right hand side, we will end up with c. On the right hand side, 100, we have two terms here multiplied together. We can separate them by doing this. Square root of 100 times square root of y squared. So as you know, square root of 100 is 10 times square root of y squared. Just like these two, these are going to cancel out. So we can just get rid of that square and square root and then bring down the y over here. 10y would be equal to c. So again, let's remember what the c was. The c was equal to the hypotenuse of this right triangle. Now I know that the hypotenuse is 10y, which is this side. So if this side is 10y, remember BD is going to be the same. So we can basically say that the length of BD is going to be 10y. This one is the last part and the last example of the video. So in this part, we are going to prove that the parallelograms that we have are rectangles. So we can use distance formula or slope formula to do this. The slope method is easier, so I'm going to use that one. It takes less time to show the word. So, and I will try to explain how to do the distance formula to prove that the parallelograms are rectangles. So the example says quadrilateral ABCD has vertices A, negative 3, 0, B, negative 2, 3, C, 4, 1, and D, 3, negative 2. Determine whether ABCD is a rectangle. So we need to go over some stuff here. Remember, we are going to use the slope formula, and we need to show that the slope of the opposite sides are the same. So slope of the opposite sides, like AB and CD, must be the same. And the second thing, BC and AD are the same. So once we do this, we are going to show that any of these angles, these angles are 90 degrees, not any of them. They must be all 90 degrees, and there's an easy way to do that using the slope. If the slopes are negative reciprocal, remember the angles between the segments are 90 degrees. So if this slope is like 1 over 5 and this one is negative 5 over 1, then we are going to say the angle between them is 90 degrees because the numbers are flipped and the sign has changed. So let's get started by doing the slope of AB. Slope of AB would be equal to, let me just write the slope formula over here for those who doesn't remember what it is, x2 minus x1. So segment AB is about these 2 points, so we are going to use x and y values of these, subtract the y values, 3 minus 0, divide them by -2 minus -3. The top, the numerator is 3, the bottom is -2 plus 3 equals 1. So now let's do the slope of the opposite side, which is side CD. These two coordinates. Subtract the y values, 1 minus -2. It doesn't matter which one you start from, by the way, but you need to continue with the same pattern for the bottom. 4 minus 3. So 1 minus -3, -2 becomes +2. It is 3. 1 plus 2 is 3. 4 minus 3 is 1. So as you see, the slope of the left side is 3. The slope of the right side is 3. So we need to have same kind of pattern for the top and bottom side. BC are these 2 points. Sorry about that. Subtract 3 minus 1 divided by -2 minus 4 equals 3 minus 1 is 2. -2 minus 4 is -6. We can simplify these numbers by dividing them by 2. The top becomes 1, the bottom becomes -3. Now, the side AD, let's find the slope of side AD. We are going to do the same thing for these two now. 0 minus -2 and -3 minus 3. The top becomes 0 plus 2, which is 2. The bottom becomes -6. The numbers are the same, so simplify them by 2. We have the same slopes. Now, as you see, the opposite sides, now let's write the conclusion. Since opposite sides are parallel, we know this because their slopes are the same. Like 3/1, 3/1. These were left and right side. This is the top and bottom side. Since the opposite sides are parallel, and the angles between consecutive sides are 90 degrees, and oops, sorry about that. And angles between consecutive sides are 90 degrees. So let's explain how we know this. So the slopes are negative reciprocal, that's the reason. We know the figure is going to be a rectangle. ABCD is a rectangle. Again, let's go over what we did here real quick. We show that the slope of the opposite sides, like these two, are the same, plus the slopes of these two sides are the same. And the angle between the consecutive sides are 90 degrees because the consecutive sides have negative reciprocal slopes, like 3/1 and 1/-3. 3/1 and 1/-3. So this leads us to the conclusion of the figure is a rectangle. So please comment below if you have any other questions, and thanks for watching. I will see you in another video, guys.